Good evening, everyone. See, we've got a good almost 150 people here, so we'll go ahead and get started. Colin mentioned in the class announcements channel that he can't be here at the beginning of class, so I'll just jump in and we'll get going on this. Tonight we're talking about interfaces and polymorphism as a kind of further delving into this object-oriented approach to coding. And it's a good follow-up to what we just talked about in the last class with inheritance, because it's important to understand the difference between inheritance and interfaces. As a reminder, this was Colin's kind of big announcement for tonight, is the student survey. For those of you who still haven't filled it out, do that during studio before you do anything else. Just get it done. It'll take 5 to 10 minutes at the most. But we really, really, really value your feedback. So we very much appreciate you doing that. Okay. Graded assignment number 2, of course, is due on October 2nd. I did not update this text. As of last class, you actually knew everything you needed to finish it, and it does not include anything about interfaces, so don't worry about that. I'll fix that later. And then the intro video, as I've mentioned before, I do have an intro video for graded assignment 2. I know several of you have already watched it. Hopefully you'll find that helpful if you are getting a little turned around with that assignment. Okay. So let's talk about interfaces and polymorphism. So the idea here is that you have different classes that may not even be related in terms of inheritance, but they might have behaviors in common. That's the idea here. So we'll talk about the concept of polymorphism first and casting with classes, and then we'll jump into interfaces. We'll talk about some of the differences between an interface and an abstract class. I'm going to touch on unit testing with interfaces, and we'll just write a couple tests for that. And then the IntelliJ Generator, I actually kind of already showed you how to do this when we were doing abstract methods, but I'll model it for you again this time around. And we are, of course, going to continue to build on the example that I introduced last time with the bookstore that has books and used books and different types of merchandise, and we'll see how that's going to play out. So this idea of polymorphism, you can have different objects that have the same behavior. And so polymorphism is the idea that you can use objects of different kinds in the same way. And you can certainly achieve polymorphism with class inheritance through casting. It can actually be done in some cases. So, but interfaces actually offer a set of behaviors that have nothing to do with inheritance. It does not matter what classes they're in. You can say, I want these classes over here that are not related to each other to have the exact same methods because they both need to have these behaviors. So that's kind of where we're headed with this. So let's talk about casting because it's just, you may not have to do this very much, but it's good to understand it. So I'm going to touch on it. Let's say you have a parent class type, but you actually instantiate child class. And so you could do that and give them that base class as a type. But then if you have a method that's only defined in the subclass, you're going to have to cast it in order to call that method. So here's an example where we take the base class book, we create a book of that type, but then we actually instantiate a used book. And because of polymorphism, this is possible. But let's say we want to see what the condition of the book is. So we go and we try to, call get condition on that book. It's not going to work because the type has been set to book and not to used book. So in order to get around this, you would just cast it to that subclass type using the casting syntax with the parentheses like this. And so you cast it with parentheses to, the object to that class. And then you have to put it in parentheses again as a whole, because you have to call the condition on it after it's been cast, if that makes sense. And that will actually work. So we can, we're going to demonstrate that. And I'm trying to decide if I'm going to just do that now. Yeah, we can do it now. Let's go over to main. And what we're going to do here is create a used book that is of type book, kind of like I showed you in the slide. We'll just use one of the ones we've got up here. And then, hang on. I'm in the wrong file. Yeah, my bad. We're going to create a completely new book. That's what I thought. I'm like, we're going to create a new used book. But we're going to give it a type book to start, and we're going to see this play out. So I'm going to say I want a book. I'm going to call it used book 3. And then I'm going to say create a new used book. And then I'm going to say it's contact, the classic novel. This is not very descriptive. Made into a movie. And then we're going to say, because this one's hard to find, I know this through personal experience, that it's actually going to be $26.75 for this used book. But it's because it's actually in pretty good condition. So we'll say that's actually very good condition. All right. And something is not quite right about this. So let me see what I've done. I'm going to then just replace this with the stuff from my other. Yeah, I don't know what I did. I must have had a small typo in there, but there we go. Okay, so so we have this used book. So here's where we're actually going to try to, call get condition, since we gave it a condition. I will just say I want to print. Let's just print used book 3 first, just so we can see what it looks like, and then we're going to try to print the condition. So I'll just say, used book 3. Oops. Used book 3 dot get condition. And you'll notice it's not even coming up, right? It's like, I don't know about that method. So we can try to do that, but it's not going to work. So instead, we're going to do that casting. So I'm going to say, I need it to be a used book. Used book 3. And then that entire thing together, I can actually call get condition. And we should actually see that then print in the console. So let's give this a run. Okay, so we see, when we print it, even before we cast it, we print it and we see that it has that property. It's been set because we instantiated it as a used booked object. But then we try to access that method, and that getter is not available because we set it as the type book until we cast it. So it's just again, this may not come up much, but it's something that's good to know about, to understand that there is a distinction there. Okay, so let's we'll come back to this code. We've got some things we're going to do with interfaces in a little bit, but let's go ahead and talk about interfaces. So interfaces are essentially a blueprint for behaviors. You cannot instantiate objects from an interface. It's not actually, any sort of pattern for an object. It's not a class, and not a regular class. So it just specifies behaviors for a class. You can also set constants into it. But if you have a class that implements an interface, then it is required to fulfill those behaviors. You have to have one of those methods with that same signature. So it's a little bit similar to what we showed last class, where we would set in an abstract class, we would set an abstract method, and that meant that it was going to be required. That's kind of the whole job of an interface, is to do that. It's like, I want you to have all of these methods. You're going to have to define them, but you don't define them in the interface. You define them instead in the class. So an interface can have constants, which are, if you remember, means you have to have both the static and the final keywords on them. You can have method signatures that are, but they will be abstract by default. You don't use the abstract keyword because it's just done by default. Static methods, and so you can define static methods as long as you're not actually referring to any kind of instance field or methods, because that's static means it's going to exist at the class level, right? And then there's this thing with default methods that you can do that's only in special circumstances. You guys do not need to worry about that. We are going to focus on, you know, abstract method signatures and constants. The other thing to know is you don't need to put the public keyword on them because they're all public by default. So the syntax is a little cleaner when you set it up. Okay, so what we're going to do with our example is we're going to say that merchandise and used books should be discountable. You should be able to put those on sale, but books should not. And remember, used books inherit from book, right? So it means we cannot pass this requirement down through inheritance. We have to have a way to say we want these same behaviors for both merchandise over here and used books over there without applying that to book, because we have just decided we are never going to put brand new books on sale. That's going to be our rule. So there are there's some syntax to this. Essentially, a class can extend one base class always, but it can actually implement multiple interfaces. And I'm not going to show you how to do more than one tonight in my lecture example, but my studio review, I do have an example of that where I've created two different interfaces and one of the classes will actually implement both of them. So you can look forward to that in the video. But you use this implements keyword. So extends is for classes, implements is for interfaces. And then that's how you assign it to a class. And then again, that ensures that class has to define all of those behaviors. And you will always use the override annotation to do that. So this example here, let me get this in front of me. Oh yeah, one more thing. Unlike an abstract class, you know, like I said, these can be applied to multiple classes that are completely unrelated because it is not passed down through inheritance. So here's the keyword implements. And you can see I'm starting to set this up. You know, I've got this interface discountable. I go over to used book and I implement discountable. I go over to merchandise and I implement discountable. This is what we're going to do. And that means that I have to define anything that discountable requires to both used book and merchandise, but not book. Okay, so I want to take a second just to clarify even further the difference. If you're having trouble in your mind distinguishing, okay, what's the difference between an abstract class then and an interface? And there are a number of differences. So I'm going to go over this before we actually get into the coding. So again, with a class, you extend. With an interface, you implement. You can apply only one base class to a class, but you can apply one or more interfaces to a class. Abstract classes can pass down through inheritance all types of fields. Interfaces can only provide constants. Instance methods can exist on an abstract class because the classes that inherit from that are going to be creating objects from that class that can have, you know, unique information for every single object for those fields. And they can have static methods. So class level or object level. When you have something that inherits from an abstract class, no problem. With an interface, you can't have any sort of instance methods. You can't refer to, you know, any kind of instance variables or instance methods. So you can do static methods though, because then you're not referring to anything that's object, you know, specific, and it's stored at the class level. So that's fine. And then of course, abstract methods, yes, they're automatically abstract with interfaces. So the usage, again, here is the distinction between the purpose of using one versus using the other. Abstract classes work for related classes. You have classes that have a lot of the same properties. They just have, you know, have a lot of their structure that you're basing objects on in common. And they can have various behaviors. You can break that down and give them completely different behaviors. But an interface says, let's take some completely unrelated classes that don't have fields in common, they don't have this, they don't have that, and let's just require and say, okay, no matter what fields you have and other methods you have to have a method called this that handles this behavior. Again, we're going to use some things that are ultimately related because they all come down from product tonight. But there are still lots of things that they don't have in common, but we're going to say that both of them have to implement some methods that allow you to calculate discounts. Okay, so let's see. Yeah, so let's go over and do some of this, and then we'll come back and we'll talk about unit testing. The first thing that we're going to need to do is I want to update our product class. Remember, this is the granddaddy. Actually, let's go over and look at this diagram. I've updated our diagram from last class. So you can see, and let me resize it just a little bit, or we may just push this over. Yep, that'll work. Okay. Okay, so you remember product is the granddaddy, right? That's the base class. And book and merchandise inherit all of their properties and methods from that. Plus, book says I also need to have an author, a genre, and a format. Whereas merchandise says I want to have a category and a theme. That's where we diverge. And they both have different definitions for, tacking on things for toString, for describing, the merchandise, describing the book. And actually, this one, we're just passing that down so it can be defined in the other classes. Looks like I've got some stuff missing here. There we go. Never mind. Okay. Used book inherits from book. So it gets everything from book, including author, genre, and format, but it adds one more. It adds condition. We need to know what condition the book is in because it's not necessarily, it's not new, it's used. And then over here in merchandise, it has children. Apparel and drinkware are the subclasses of merchandise. And drinkware introduces material and ounces. Apparel introduces sizes and colors, and they have their own, in some cases, additional methods that support all of that functionality and those properties. But we are saying we want to have it where merchandise and used book can be discountable. So you'll see this dotted line. This is the way to point to the interface that they should be implementing. And so we don't have it coming from book. We only have it coming from used book and merchandise. And this just says, I want you to have 3 methods. You can define them, whatever works for your particular class. But here's what we want to do. We want to have a way to apply a % discount, a way to apply a flat discount, and a way to remove a discount and, put it back to the original price. That is what we're going to do. We're going to take what we had. But in order to do that, we need to be able to track an original price versus a current price. And last time we just had a price.
Oh no, not headmaster.
So we are going to take this and just refactor product just a little bit so that we can turn our price into both an original price and a current price. So let's do that first, and then we'll modify the things down here that we need to, the methods, accordingly. And then we'll actually go write our interface, and then we'll implement it in both merchandise and used book, and we'll do it a little bit differently. Okay. So right here, it says refactor to set both a final original price and a current price, and also update the toString. And we're going to have to update, getters and setters. So I'm going to say right here, I want private final double, and I want original price. And then that means I need to set original price here to price. Now, we're going to pass in a price. We're going to keep the parameter the same. And what we're going to do is have another, and this one's not going to be final because it can be changed. We're going to have one called current price that we do the exact same thing. We just set, when we first create the object, we just set both original price and current price to price. Because they are the same when you first create it. The current price is only going to change when we have some sort of discount applied, right? So now that we have these two, we need to come down here and make some changes. We've got get price and set price. So I'm going to get rid of those. And I'm going to say I need just a getter for original price because it's final now. But I want getters and setters for current price. And then when we come down here, we need to update our toString method as well to represent these new things. So I'm going to say original price, and then we'll duplicate that and say current price, so that when we print out all the information about our object or our product, we will know the difference between the two. Okay, and then everything that inherits from this will have those same lines in their toString automatically. Okay, so that I believe is everything we needed to do for that to do. So now we can go over and we can write this thing. There is one more thing I want to point out. You may have noticed this on the diagram. I have a utils class I added here with just a single static method that we can borrow from for writing our discount methods, called round to penny, just to give us that rounding to 2 decimal places anytime we do the math with our doubles. So we'll be using that. But for now, let's right here at the level of the class 7 package, I'm going to add, and so you go to class, you say, I want to add a Java class, but then it lets you choose exactly which type. And I'm going to choose one of the special types, which is an interface. And I'm going to call it discountable. You'll notice I'm naming it in a way that says that, makes it clear that I'm applying behavior. I'm making something, an object, discountable. And that's a good practice to get into. Makes it really clear that it is an interface. Okay, so we're going to have 3 things that we want to require. We said on our diagram that we wanted apply percent discount. So I'm going to say void apply percent discount. It's void because it's just going to use the setter for the current price to set a new current price, and it doesn't actually return anything. And we will specify what percent to apply. We will have a apply flat discount. Same thing, we're going to have a double that's an amount. And then we'll also have remove discount, and that one doesn't need a parameter. It just means we're going to set current price back to original price. Okay. So we've got our definition. This is all we need to do for the interface. Interfaces are generally pretty clean because all you're doing most of the time is just providing the signature is the word I'm looking for. The signature for what's required, much like you do with an abstract method in an abstract class. So we've got our interface. Now it's a matter of just going and implementing it. Let's start with used book. So we need to implement this. So we are going to go right after extends book. I'm going to say implements discountable. Okay. And now it immediately says, if I hover over this, class used book must either be declared abstract or implement abstract method apply percent discount in discountable. So it says, yep, we've got some stuff that's required now that we need to go define. So we'll come down here to the bottom. And this is where the IntelliJ Generator comes in that I'm going to mention later. I'll just go ahead and show you now. Just like I did before with the abstract classes we got last time. You can use the generate thing and go to implement methods, and it'll show you what's available. Well, I say what's available, what's required by our interface in this case. You also can get to this by, oops, I don't know what I just did. Okay, there we go. You can also go to override methods, and that's where you see not only the things that come through inheritance, but also down here you see the interface as well. That gives you everything that could possibly be overridden through both inheritance and interfaces. I tend to just jump straight to implementing because then it gives me just the inheritance, and that's all I really want. Okay, so now I have the signatures and empty bodies here for all 3 of these. And so now it's just a matter of putting the code in that defines them and makes this happen the way that we need it to happen. And there's no like fake return value here, like return 0 or return null, because we said it was void. But otherwise, it'll probably, provide something like that when you first do this with the generator. And then you just have to replace it. And I just noticed we also need to override, I'm sorry, we need to update this, right? Because it still is using that old getter for price. And we need to say get current price here. We're probably going to need to do that in several places, actually, now that I think about it. Yep, sure enough. All right, let's just go to all of our subclasses and get it over with while I'm thinking about it. We'll do it in drinkware. Yeah, these are all formatted a little bit differently, so that's why you have to do it in every place. And we don't need to worry about it there. Okay, so back to used book. Used book. Yes. Okay. We are going to start by saying, so here's kind of the distinction in the behavior that we want to make between used book and merchandise. We're going to say that with merchandise, we want to allow that if something is discounted once using either a flat or a percent discount, if you come back and you try to apply a second discount, it's not going to apply it on the current price. It's going to apply it on the original price. So it can only ever be discounted off of the original price, even if you change what the amount is, flat or percent. With used books, we're going to say, you know what? When we keep discounting those suckers, that price just keeps getting lower. We are going to allow it to just keep calculating on the current price instead of the original price when we add additional discounts. So that's going to change some of our logic here with how we handle this. All right, so let's let me get notes here. Yeah, okay. So I'm going to be, when we do some formatting, I'm going to be using this new line a few times. So I'm going to go ahead and add this in. I'm going to create a new line character with system.line separator, and then we'll just have it when we need it. Okay, so first we are going to take the percent that's been passed in, and we are going to actually put it in decimal form. So this is kind of like it's just a protection, because what if somebody goes ahead and passes it in as a decimal? Well, no problem. But what if they pass in 50 when they mean 0.5, right? We're just going to check for that and just say, if the percent is greater than 1, because they're thinking, in terms of whole numbers, then we just want to take percent and update it. You don't see this too often. This is kind of like a plus equals or a minus equals, but it's divide equals, where you just take the previous value and update it by dividing 100. And that way it'll now be exactly what we need it to be. And yes, I know it's not used yet. It's okay. All right. So we have a couple things here. Because we said that we were going to allow it to be for a used book, we're going to allow it to have additional discounts on top of discounts. We have to have a little bit of logic here where we change the way we're doing this. And this is just really mostly for messaging, but we're going to say if get current price equals get original price. Oops. Hit tab too soon. Then we're going to kind of have one message, and then otherwise we're going to have a different one. So we'll take care of that in a second, but let's actually do the math, right? So we're going to say new price is going to be get current price, and then multiply it by 1 minus percent, so that new price represents the price after the discount. And then we can actually set the current price And we'll take this, remember I said I had that round to penny utility function. I'm going to take that now utils dot round to penny and say, apply that new price, but make sure it's rounded so it's, only 2 decimal places. And then we set the current price and we calculated it, off of the current price. Like we said, we can have multiple discounts. So now, just for the sake of having multiple messages, we can come in here and just, basically say, a discount of this amount. And here I am actually multiplying it back times 100, because when we talk about it, we do it in whole numbers. And I add the percent sign, has been applied to product. I'm going to give the ID. I'm going to give the name. Otherwise, I'm going to say additional discount. It makes it clear this was a discount on top of a discount, because the current price and the original price were already different. So that's gonna be all there is to it. That's applying a percent discount. So we can do that, and then we can also apply a flat discount. Let's work this one out. So again, I'm gonna have this new line that I'm gonna use a couple times, and then this time I can take oops, let me go back here. I can take what I had before and just modify this. So this time I'm going to say, rather than saying we'll have some sort of percent, we're just going to say amount. And then we can take the percent sign off and just say it's been applied to the product. Everything else is the same. So let's just do that here again. So I got an extra space, amount, take off the percent. And then that message works out just fine. But we have the same logic. It's either an original discount or it's an additional discount. So those are the hard ones. Remove discounts are real easy, because all we have to do is take our setter for current price and say get original price, because remember we made that final. It's never going to change. We can keep, always keep that on the back burner, and it's there for us, waiting for us whenever we need to reset it. And then we'll just have a message to the user, and I'll copy this over actually, so I don't have to print it. Type it. Okay, yeah, used book with get ID and get name has been reset to the original price of $, and then we say get original price, and then just add a little space so it's more readable in the console. Okay, so that allows us to handle all 3 of these situations. So let's go over and try it out. Let's go back to main, and we're going to test these discounts here. And I'm just going to use some, I still got these original objects up here that I created last time. These still work for us. Remember, the signature didn't change when I created original price and current price, because I'm still passing in just a single price. The parameter is still the same. So these are all perfectly fine. So let's just come down here, and what we'll say is, let's take, for instance, used book 2, which is the Agatha Christie book. Let's take that and say, let's print it first, just so we can see what it currently is. And then let's go ahead and do this. Yeah, okay. So right now we see this book, and then we see that it is got an original price and a current price that are exactly the same, $4.75. So we can come in and we can say, okay, no problem. Let's take this and used book and 2 and apply percent discount of 50%. So I could put it in as 50, I could put it in as 0.5, because my code handles it either way, right? And then we could print it again. to see how it has changed the current price. All right, so now we see the current price is $2.38 because we put that sucker on 50% sale off, 50% off sale. Wow. All right. Let's do it again. Let's say, we're just going all out on a major clearance here. We want to get rid of this book. Let's apply a flat discount. And we'll take off, $1 more or something. And then I really should have done these the other way around, but that's okay. And we'll say, print used book 2 again to see the updated amounts. Okay, so originally the same price, then it was $2.38, and that did not work. What did I do? Additional discount of $1 has been applied, but it didn't update it. Okay, interesting.
You forgot to update the code for the flat discount.
You're right. I didn't finish it. Thank you. I mean, that was my next guess, but yes, you're absolutely right. Okay, so we can basically do the same thing that we did here. We're just going to do subtraction instead of applying. We'll just subtract amount, and then we'll take that new price, and it's probably not necessary to round it if it's already, to 2 decimal places, but that's okay. We'll keep it the same. We'll use the round 2. Okay, so yeah, so if I run this again, it should be fine. All right, this is why we test our code. Okay, so yeah, there we go. And so now we see, oh, now that's hilarious. 1.38. This is exactly why I have the rounding, is because it does, computers are weird and it does this, but sometimes it's so goofy, even when you try to round it to do 2 decimal points. All right, I'm not going to worry about that right now. It can be tweaked to prevent that, but anyway, but we see it has another $1 off, right? Isn't that funny that it did that? Let me take it. Let me actually, here's what I will do. I'll take it off and just say, let's just set it to the new price because it shouldn't have changed the decimal amount. Yeah, that's better. Okay, cool. All right, so we are done with used book. We have exactly the behavior that we said we wanted. We fulfilled all 3 of these required methods coming from the interface. So now we just need to do the same thing over in merchandise, except, we want to have slightly different rules. So we're going to implement discountable. And so that means that down here, we need to come in. I'm going to use my generator and go to implement methods. And I'm going to say, yes, I want all 3 of these. And now we can define them. Okay. So if we go over to merchandise, this is going to look a lot like the previous one. So really, I could borrow from used book to start. So I'm gonna copy this, and we are going to just do a little bit of tweaking on it, really. All right. So we're going to start by doing the same thing, make sure we account for the fact that someone could put in a whole number or a decimal number for to represent the percent. We're going to have logic here, but only so that we can make it clear that we're either overriding the previous discount or we are applying it for the first time, not necessarily in that order. So this is going to be the same. Discount of has been applied, but here, instead of saying additional discount, we're going to say original discount, and then let's see. Nope. Here, I'm just gonna copy this. It'll be easier. We're gonna say that the previous discount has been replaced, essentially. Yeah. Previous discount on, get name has been replaced with a discount of, and this is where we do the calculation, plus the percent sign. So it is very, very clear to the user what has just happened. We're not, tacking on another discount, we're replacing the previous discount. Okay, and then this part is all the same. So we have that, and then for the flat discount, we're going to kind of do the same thing. We're going to use this and then just change that language. Sorry, it isn't exactly the same. I do need to fix something. Okay, so the calculation has to be on get original price. Can't be on current price because we said we weren't allowing it. So I do have to change that. But for this one, we can do the same thing. We can change the language, and then we can also change the calculation to make sure it calculates on the original price. All right, so I'll replace this to where it says previous discount has been replaced with a discount of $ amount. And then here we'll say get original price instead of get current price so that it calculates only off of that. And then it sets it for us as the new current price. All right, remove discount is going to be pretty much identical except for the language. So let's come over here, and I'm just going to say, instead of used book, I'm going to say merchandise has been reset to the original price of, because that's always true. Yep, we're resetting. So that part's also, yep, cool. All right, let's go test it out. I'm gonna come over here to main. And we'll use a hat. How's that? We've got a hat up here, our Captain America hat. All right, so let's go ahead and print it just so we can kind of see how it starts out. And then we'll apply the first discount. And why don't we this time, let's say, do the flat discount first. So I'm going to say hat.apply flat discount, and we'll just say, let's take $3 off. And then we'll print it to see the difference. And then we'll apply the % discount, and we'll say, we're going to take off 50%. I'll use 50 this time just to prove that both 0.5 and 50 produce the same results. And we'll print it again to check it out. All right, let's do it. Okay, so we start out with a hat that's $19.99. Not bad, I suppose, as hats go. And then we discount it by $3, and now it's $16.99. But then we say, okay, we want to apply 50%. So it says previous discount has been replaced with a discount of 50%. And now we see that it's $9.99, not $8.50, right? Which would have been if it had, applied it to the current price instead of the original. Yeah, so that's working for us. Okay, let's see. I think that's everything we needed to do for all of this until we get to the unit test. So who has questions? I want to stop and take questions. I honestly don't remember. Yeah, I don't have my slides all in the right order. So let's just do, who has questions? Melanie.
I was wondering why exactly we would use polymorphism. Can you give us an example?
Well, okay. Sometimes you have things that you might be, yeah, not easily. No, I mean, it's not something that comes up super, super often, but every once in a while you might be working with something where you're generalizing on something like, let's see. So we had, like, let's say we had something that we were doing where we were making a list of merchandise. And so we were allowing you know, objects of apparel and drinkware and merchandise, excuse me, apparel and drinkware to all be, you know, kind of treated in the same list. And they would have to have a parent class that wasn't abstract, but hang with me here. So you've got these subclasses that have a parent class, and we just decide we're going to type the list as the parent class because that way it works for all of them. Okay, we can use our beverage class, right? If I want to have a list of beverages, that could be soda, it could be diet soda, which is a grandchild, it could be juice, it could be water. And I can have a list with all of those things in it because of polymorphism. You can have, you know, and just say it's a beverage. But then let's say you're in there and you've typed it as a beverage, but now you're in your method and there's something that you want to do where you want to, maybe you're using some logic and saying, hey, if this is an instance of juice, run this method that only belongs to juice. That's where you have to cast it because you originally typed it as beverage in order to have it in the list.
Makes sense.
You don't necessarily strictly have to do that, but sometimes that is the way that it is. So yeah, that would be an instance of where you might do that. Yeah.
Thank you.
Yeah. Anybody else? Is anybody still struggling to understand when you would use an interface versus when you would use inheritance? Anybody got any questions about that? I think that's usually the hardest part for everyone, is just understanding why you would do things one way versus the other. No?
Do you mind going over that one?
Sure.
Why you'd use one over the other?
Yeah. Okay, so I'm going to go back here. So the distinction is that with inheritance, you can have various behaviors, but the properties and it's like the essences of the objects are mostly the same. And so you're passing things down through inheritance when they have lots of properties in common and instance methods. And then you can kind of branch off from there and you can apply, you know, other methods to them individually that might be just really various behaviors. But with an interface, you've got two things that really don't have a lot of properties in common necessarily, but you can apply interfaces to say, I want you to have these methods. My lecture example does not make that as super clear because ultimately all of my stuff does actually inherit from product. So they do have a lot of the same properties and things, but my studio solution for tonight, once we get into the bonus missions, especially, you're going to see examples of where we have two things that have very little in common, and I'm requiring the same methods of both of them, but the way I fulfill them, the way I define them is completely different. So that's when you want interfaces.
Gotcha.
Yeah.
Thank you.
Yeah. Okay. Let's see. I'm going to go ahead and jump ahead to the 5-minute break, and then we'll come back and we'll talk about unit tests, and then I'm going to get you guys off to studio because you have a lot to do tonight. I'll talk about it later. All right, let's do break. Okay, welcome back. I need to actually go backwards in my slides. So give me a second here. Okay, so let's talk about unit testing. Unit testing with interfaces, basically the goal is just to make sure the interface is being used correctly, and that any methods that are created to fulfill the interface requirements works correctly. But you don't test the interface directly. You just test the class that implements the interface, and you test the actual methods that have real definitions and are working with, the information from that particular class. So you want to write the tests that are just checking those behaviors. That's the whole point, right? Make sure that they've been defined properly, they're working as intended. So we're going to go over and do this. I have a used book test over here in my test hierarchy for the books class for class 7. So let's come over here to that file. And I've created a used book. I declared a used book Horton. And then here I'm saying before each test, before I actually make changes to it. This is why before each is important, in case you haven't caught on to this yet. You need a fresh object every single time if you're going to manipulate it, because you don't know what order the tests are going to run in, and suddenly the amounts that you're expecting may change, like the values may change. So before each allows you to say every single time you run a test, let's just give a fresh object for that variable, and that way it will be as if you didn't operate it at all on the other tests. So I've got it, Horton here's a who, and we have, all the required parameters here that are being fulfilled. So we've created this object. So I've written a couple tests already here that check for the percent discount. Can receive percent discount is what I named it. I came up with a message. A new used book object can be given a percent discount through the discountable interface. And so I apply the percent discount. I act on my code, give it 50% discount. And I say, here's what I expect to see. If it was $12, I now expect to see that it's $6. And then I'm going to check that current price, actually accessing the real object. And then just do my assertion to compare them. And I'm setting my delta as 0.0 to say I expect them to be exact. So, but if you had calculations where you weren't doing some of the rounding I was doing, then you might need to actually allow for a slight variance because of those rounding issues. So I did the same thing with flat discount, and I said, okay, apply a flat discount of $2. And if that's the case, then I would expect that something that was $12 is going to be $10. But what I haven't tested yet is what happens with a used book object when you apply multiple discounts. Because we did say that with a used book, it's, we wanted it to specifically follow those rules, that we will allow you to apply a second discount that calculates on the original one. Everybody check your mics. Okay, so we're going to do that, and then we're also going to test our third required method, which was to remove a discount, right? Okay, so let's come over to this file, and we'll just call this next one, and remember to use your test annotation there. And then I'm just gonna say, this is public void can receive multiple discounts. And this is a test that I would not have if I was testing merchandise objects, you know, or one of the classes of merchandise, because in that case, the behavior is slightly different, right? Okay, so I'm gonna start out with my message. I'm just gonna say a new used book object can be given multiple discounts through the discountable interface. So I'm making it clear with my message here that I am specifically making sure that the things that are affected by the requirements of the interface are what we're testing. So I'm going to start with Horton and say apply a flat discount of $2. And then I'm going to say, let's apply another discount. This time we'll do a % discount and we're going to make it 50%. And then after we've done both of those things, I'm going to say that the amount that I expect is now going to be $5 because I took $12, I subtracted 2, and then I applied 50%. Expected equals, let me finish that. Okay. And then on the actual, I can go and access the current price with the getter, say Horton dot get current price, and we're going to compare those two. So I will assert equals and say expected versus actual. We'll say that it's 0.0 on the delta and then say message. Okay. And let's run it and see. Okay, discount of $2 has been applied to product 1. Horton, here's a who. Additional discount of 50% has been applied to product 1. Horton, here's a who. So you can see that, our little printout messages have run and the test passed. So we're good on that. So now let's do the last one. We're going to write a test that just demonstrates the discount can be removed. So I'll put my annotation on. Public void can remove discount. All right. String message is going to be a new used book object can have its discount removed through the discountable interface. All right, and we will say, first we apply a discount. Remember, we're starting with a fresh object every single time because of before each up here. So I have to actually act on it to apply the discount before I can demonstrate that we can remove it. So we'll apply that $2 flat discount and then we'll remove it. Horton.remove discount. And I'm just going to say that the expected amount is actually, expected amount is going to be, 12. And another way that I could test this if I wanted to is to use the getter for original price, because we're testing that it should have been returned to the original price, but this will work. Hard-coded values are the norm for expected values usually, so that's fine. And then we'll say assert equals and do our expected just like before. And I mentioned this before when I was talking to you guys about these tests. You don't have to break this down into all of these variables if you don't want to. I could have just put 12 here and I could have just put Horton.get current price here. But because I want you guys to I want to be very explicit about every step of the way what's happening here, just because you guys are new at this and don't have these things memorized yet. Okay, so let's test this one. We'll run it. There you go. Discount of $2 has been applied. And then here it says it's been reset to the original price of $12. It's not formatted perfectly, but that's okay. So anybody have any questions about this, about what I just did? Nope. Okay. I didn't necessarily expect you to have any. It's pretty straightforward because we've been doing tests for a few classes now. All right, so let's talk. I did this for you earlier, but here's the slide about it. When you have the interface created and you've implemented it at the top with the implements keyword, IntelliJ now knows here are the things that are required. And so you can use the generator to do that, and just use that implement methods from the generate menu. And then it gives you, exactly what is needed and you can throw it in. So you watched me do this, right? And then all you have to do is code the body. So that's all there is to that. Yeah, I have to go back through this, don't I? Okay. Here we are. Okay. Sorry, got my slides all turned around today, apparently. Okay, so what you've got coming is Spring controllers and routing. Then we'll talk about exceptions and IntelliJ tools. And then you'll have your catch-up class on the 28th. And then the following class, we're going to get into Timeleaf, which is, if you haven't looked ahead yet, Timeleaf is a something you can use with Spring Java products to actually style and compose the stuff on your web page without having to have a completely separate front end, like you would with Angular or React or something. And then your graded assignment 2 will be due that day. So that's that. Let's talk about Studio. I don't know how you guys felt about your Studio last class, but it was a monster, was it not? And tonight's is not going to really be any different if you decide to do the bonus missions, especially. The idea is that you're going to have a base class called base disk, and you are going to use that to as a base class for subclasses CD and DVD. And then you're also going to have an interface that will just define some behaviors that they have in common that you want to apply without having those methods come down through inheritance. So you're going to, have some things over in the base class and some things over in the interface, and then, apply them to each of those subclasses. But the thing is, the bonus missions would invite you to add 4 more classes that some of them are wildly different. So let me actually just go over the instructions here. Here's my advice to you. This is what I'm going to say. Focus on CD and DVD. Come up with something that works just for those two for the sake of your studio time if you want to actually get it done. I know that some of the TAs are talking about doing this as a group. And if you don't do it as a group, do it with pair programming or a group of 3 or 4 or something. Just like last time, I think it'll benefit you to work together because you need to kind of bounce ideas off one another to come up with something in a short amount of time. Having to design something virtually from scratch is a lot of work. It's harder when you're pretty new at this, right? Much less than take that design and code it. So do that. But then if you really do think that you want to tackle, and I know some of you do want to tackle all these bonus missions, then you can go ahead and look at what's going to be required by that. They talk about what if you had a vinyl record, like what if you had a floppy disk? These are things that spin, right? They're not the only kind of flat circular media that there is out there. What if you had other types of spinning disks that aren't media? What if you had wheels and frisbees, right? Things start to really diverge, and you could say, oh, well, maybe there's something that, vinyl records and wheels and frisbees have in common that, these other things don't, and, that kind of thing. And that's where the interfaces come in. My solution, which I don't actually have the video on YouTube yet, and it might take me a little while to get to it tonight. But it's the solution's done. My solution is going to cover all of it. And what I decided to do, unlike last time where I kind of like coded the main solution and then just said, okay, and here's the bonus missions, I'm going to show you where I'm headed from the beginning, because if I just design it based on CD and DVD, I probably am not going to land in a place where I can then just easily refactor it into all 6 of those classes. So I decided to go ahead and just say, how am I going to design this if I'm aware of the needs of all 6 of these classes? So this is what I'm saying to you is, you can make that decision of, if you think that you're going to go for, the gold and just go all the way through, Your approach may be very different, but for the sake of class and working together with your peers, definitely just focus on CD and DVD tonight because it's probably all you're going to have time for. That being said, I'm finishing 20 minutes early on purpose because I want you guys to have more time. So I will let you guys know in the class announcements channel when I do have the video up. But like I said, it very well might be pretty late tonight. And it's going to be long, just like the last one. It's going to be pretty long, so you're probably not going to watch it tonight anyway. But I'll let you know. All right, you guys head off and have a great evening. And I will see you Thursday to start getting into spring.